Howdy tubes, welcome back to the Zach Life. So this is going to be the electrical part one. Now I'll say right now there's not going to be much electrical in this video, and I'm shooting the intro after I've already done everything else. You know, I kind of do all this backwards, it makes it confusing. I want to install a breaker box, a couple of plugs, the air conditioners are going in, we're going to kind of wire the air conditioners up. Going to be a few things at the end, but most of this video is going to be set up and pushed for somebody like me that wants to build a motorhome that hasn't thought through the electrical system, or wants a couple of good pointers or some good ideas. Now, if you don't know me personally, I am an electrical geek, nut, whatever you want to call me. As far as like HMI, PLC type stuff, variable frequency drive, RC, that's kind of my gig. Now, this motorhome is going to be no different. I like things that are over-engineered in a way that they don't give trouble, and things that are very automated. I like things that you just sort of have a go button. You hit the green button and you forget about it. That's what I like, and that's what I'm going to try to do with this coach, to make it work very well off-grid, to be relatively fuel efficient. And I know I've got a 100 horsepower Detroit engine in there that's pulling the generator, so it's not going to be very fuel efficient, but as fuel efficient as you can make something like that. As electrical efficient might be a better terminology. But anyway, I'm going to go through kind of step by step of the systems and how it's all going to be hooked up and how everything's going to be all tied together in this motorhome. Now, 2 days ago, I shot a little sequence in here about the air conditioner control systems, and let's cut to that, and I'm going to talk about that first. Okay, very briefly, here's a little thermostat. This will control up to 4 air conditioners, and here's a control board for the actual air conditioner. These are connected via like a telephone cable. I believe it's RJ11. Now, one thing to note, I don't understand why this is, but most of the time when you buy a telephone cable, the polarity is switched on either end because the phone doesn't care the polarity. So the center two conductors will be red and green, and they'll be actually switched on each end of the cable. So even though a phone cord will plug into this, you can't use a phone cord to control this, because this is sending 12 volts DC over this cable to operate the thermostat, and it's got to be polarized correctly. You can't have the positive negative switched. I was trying to get this to work on the bench here, and I gave up. It kept having an error code. But what I wanted to show is it's got 2 extra relays in it that you can do several other things with. And one of them is what they call a load shed. So anyway, the deal with the load shed relay, and I don't remember exactly what I explained, I'm going to probably repeat myself here, is basically another relay that corresponds with the compressor relay. So when the compressor kicks in, it closes a single pole, single throw relay set of contacts. And what I'm going to do is I'm going to loop in series all 3 of these sets of load shed contacts, so that whenever all 3 compressors run simultaneously, it'll have continuity between those 3 sets of contacts. Now, my hot water heater, my cold water heater, they're not, if it's a hot water heater you wouldn't need to heat it, I think, and this hasn't been determined, but it's going to be like a 6-gallon 20 use 1500 watt ish 120 volt single heating element water heater. Along with that, I'm going to have a 13 kVA or kW instant electric hot water heater, and it'll be plugged in with a 50 amp plug separate for the motorhome, and it'll go back to the generator. We'll get to that in a minute. It's going to be obviously a 50 amp unit. It's got, if you don't understand 50 versus 30 amp, 50 amp is a 240 volt 50 amp plug called a NEMA 14R-50, I think. I could be wrong. It's 240 volts, 50 amps. Now, in some RV parks, it'll be 208 volts, 208, 120, because it's a Y Y transformer configuration 3-phase, and you bring in 2 of the Y phases with a neutral, and you get 208 volts, but you still get 120 volts on each side of it. But anyway, the one side, 50 amps of this, so 120 volts, 50 amps, is going to power my 3 air conditioners and the hot water heater. Now, I'm on the load shed relay. When all 3 compressors run, I get continuity through all 3 of those sets of relays. I'm going to have a single pole double throw relay that powers the water heater, so that when all 3 compressors come on, it opens the circuit and turns off the hot water heater. And so that'll keep me under that 50 amp threshold. Now, I realize these are 50 amp plugs. I don't abide by any rules whatsoever. NEMA or NEC, either one. I want to probably actually put a 60 amp breaker, main breaker, both in the generator and the main box, so that I'll have available 60 amps at 240 volts from that generator or from my shop. Now, I realize that this is overloading that plug, but in most cases, like where they'll be plugged into my shop and stuff, if it catches on fire and burns up, it's just going to make a little smoke, and the plastic's going to melt off the plug and the breaker trips. So I'm not too worried about that. I'm going to have a breaker box mounted back on the generator. Now, my generator is a 38 kVA at 120, 208, or 277, 480. Obviously, it's wired, low voltage. And 38 kVA at 208 volts is 105 amps or somewhere thereabouts. Now, if you don't understand generator windings, this may be kind of confusing, but it is no longer a Y12208. It's wired in what's called double delta, and this will actually give you a true single phase 120 240 opposing phase power out of a 3-phase generator, and it's wired. That's how it's wired. It's double delta 120 240. Now, the problem is you're still limited on your output leads to that of the maximum winding current. So it's still limited to 105 amps at 240 volts, which instead of now being a 38 kVA generator, it's like a, what is that, 100, like 26 or something. Typically, and that's continuous, typically standby power generators can have an increase of 10% per 1 hour. So that thing should be good for 120 amps for 1 hour continuous or 1 hour standby usage. Now, I've got plenty of horsepower to pull it. I just don't have all that much generator. So anyway, back at my generator, I'm going to have a breaker box with 2 60 amp breakers. And those 2 breakers are going to feed 2 14R50 typical 50 amp RV plugs. It's inside the box that my cord winds up in, that you pull out to plug your coach in with. And so when you're using the generator, you'll simply plug that 50 amp plug into that 50 amp receptacle inside that little box where the cord winds up, and then it'll have there's 2 60 amp breakers feeding 2 of these plugs in the electrical box. One will be for the main coach, and then the other plug will be the 50 amp RV plug that's going to power the instant hot water heater, the 13 kW water heater. Now, this plug that comes into the RV, the part that powers the motorhome, is going to come into a breaker box that's underneath the sink. Now, inside this breaker box will be a transfer switch, a 60 amp main breaker instead of a 50. I want a 60 amp. The power out of that 60 amp main breaker will go into a transfer switch, a double pole double throw relay. Out of that transfer switch is going to go across the floor up into the main breaker box that you're going to see me mount here at the end of this video, that's actually got all the breakers for the coach. So I know that sounds like a lot, but that's the easiest way I can think to do this, to have a breaker box on the generator, a sort of main breaker box, and then the main breaker box has got all the breakers in it. Now, this the box that's got the main breaker in it will have an additional breaker that will power a converter, or actually a set of them, that converts 120 volts AC to 50 amp 28 volt DC. And we'll get back to the DC in just a minute. Hold that thought. The reason I had to have this other box is I wanted to be able to, let me back up. I want to put a 5,000 watt pure sine inverter. That pure sine inverter will feed into the transfer switch, and that transfer switch will give you the option, or actually be automatic, to switch between shore power / generator, if you got it plugged into the generator, and the power inverter. Now, if you get in a situation where you've only got 30 amp service, or you've only got 15 amp service, or whatever, you can actually use the DC converter, the 120 volts to 28 volt DC converter, to charge a set of batteries, which is going to have like a golf cart set of batteries under the floor, battery bank. Out of that battery bank, you can power your inverter and have the inverter power your coach. So if you want to do something like run your air conditioner and cook breakfast all at the same time, you won't be limited to that 30 amp service. You're simply using that 30 amp service to power and charge your batteries, and your batteries are being drawn by an inverter to power your coach. Now, if you remember also, my generator has got a 270 amp 28 volt alternator. This alternator will charge that battery bank. So if you don't want to run your generator at full power, if you're not using that much electricity but your batteries go dead, you can simply crank that generator up and let it idle, charge your battery bank up, and then you keep running your coach off your battery bank. Now, back to this breaker box I was explaining. I had to have a separate breaker box to have breaker protection on my 120 volt to 28 volt DC converters, because I want to be able to run those and power those with my transfer switch to inverter, so that my power cord coming in and the inverter are isolated, but that the charger is drawing power off the cord. Does that make sense? That's kind of hard to follow. You know, if you had your battery charger is running off of your box that's got all the breakers in it, it would be running off the power that the inverter is making. You know, it'd just be a loop. So anyway, I'm gonna have 3 breaker boxes. That's sort of the AC system. Now, I'm gonna go over real quickly. I've got an 8 circuit breaker box. So we've got 3 20 amp circuits for air conditioning and 1 20 amp circuit for the water heater. Now that's half of the breaker box. That's one of the 120 volt legs. On the other side, so I've got 1 circuit that's going to power all of the receptacles in the coach. I've got 1 circuit that's going to power all the lighting, a small electric heater that's going to be in the like a heater ventilator thing that's going to be in the bathroom. It'll be on the lighting circuit. And then I'm going to take a 30 amp circuit, and I realize this isn't up to code, but in my experience it won't have a problem. I'm going to take a 30 amp breaker and pull a number 12 wire off of it, or actually 2 number 12 wires. And from this 30 amp circuit, I'm going to put 2 plugs over it's going to have a table. I guess I probably should be able to explain where it's going to be at. But I'm going to have a table that's going to be sort of be able to use as a cooking area. And then the same 30 amp circuit is going to go over to where the sink is, and it's going to have 2 receptacles powered off this 30 amp plug where the sink is. And I'm going to use these 4 receptacles to do my cooking, like a George Foreman grill. It's not going to have a stove. It's going to have a set of induction hot plates. You can plug 2 hot plates in, and this gives you the ability to run at least 2, if not 3, of those high wattage cooking appliances in there without having to, you know, figure this plugs on this circuit, this plugs on that circuit, you know, whatever. Keep all that stuff straight. I think this will work good. Now I realize that number 12 wire and these 15 amp plugs are going to be considerably overrated, but I don't think that this will be a problem. And I did some tests pulling 30 amps through number 12 wire, and I really didn't have any temperature problems whatsoever. And usually it's going to be split up on these either two wires, one going each direction. Now on the outside of the coach, sort of in the middle of the coach, on either side, I'm going to put an external plug, and it'll be hooked in as well to these 30 amp circuits, and it's going to be on the outside of the wall of where the plugs are on the inside of the kitchen. And then the last remaining circuit is going to go to a convection microwave. All right, this is a high voltage. Now let's get into the DC stuff. So I'm going to have two different DC systems. So there's going to be the truck. Now the truck used to have what they call a series parallel switch, and it's gone. That 1693, the glow plugs glow and the starter cranks on 24 volts. That truck has got 4 Group 31 batteries with 2 sets of batteries in parallel and 2 sets of parallel batteries in series. So you've got 2 sets that make 12 volts, and then you can cook all 4 of them together and you make 24. It's going to have a small, like a 10 amp marine onboard battery charger that hooks up to this 2 sets of truck batteries. And so I'm gonna, I'll have a switch to disable it or something in my control panel. I'm gonna put a sort of control panel in the closet. It'll be like a small closet door you open. It'll have all the gauges for the generator, start, kill button, and all the switches to control everything. But anyway, it's going to have like a small 10 amp charger that'll keep that set of truck batteries hot. Both the set that only it starts on, the 2 wired in series, and then also the 12 volt ones. Now, what this will let me do is if I'm going to pull up somewhere, say at a truck stop, and not leave the truck running, or wherever, that 359 has got a different switch for the running lights and for the parking lights. So you can click the running lights on, it turns on the 5 cab lights on top of the truck. And I plan on taking that same circuit and hooking up a couple of maybe like the lights on the 4 corners of the coach. So you flip that switch on, and it just sort of gives you a perimeter light. So if somebody's driving up, they can't miss you. Or if somebody wants to assassinate you, they can, shoot you through the, across the pasture because they see you or something. But anyway, if you want to leave those lights on, this little 10 amp charger will keep that battery hot. Obviously, too, if the thing sits for 6 months, you can leave this thing plugged in and then go to float charge and keep that charged up. Now, there's a few things in this motorhome. This air conditioner control system will be one of them that will require 12 volts DC. Now these will be very small sort of phantom loads and some gauges and a few other things, and I'm going to hook those up to run off the truck batteries, just because it's a 12 volt system that's already there. It'll be equalized. If I try to hook that 12 volt system up to my big 24 volt bank that's going to run the coach, you could get the batteries out of equalization. It'd just be a pain. It'd just be easy to hook it up to the truck batteries. Now the generator will start, run, and control and everything off of 24 volts. It's got a 24 volt starter, 24 volt alternator, and all the control systems will be 24 volts. Now it's going to actually crank. The starter is going to be attached to the truck batteries. It's going to actually with the truck batteries. And the reason is if I hook, I don't know this for sure, but I have a hypothesis that if I was to hook the starter up to my battery bank that's going to power the coach and my inverter, that when you went to start it, it's going to pull such high current, the starter is rated at 1,000 amps, that it would cause the voltage to drop enough that it would trip the inverter out. The inverter would trip for low voltage. So it's actually going to crank off the truck batteries. Now the alternator and the control systems will all be attached to my set of golf cart batteries that run the coach. It won't draw from the truck batteries while you're using it, only when you actually crank it. I'm going to pull several big cables of OSSW portable power cable. You can buy sort of like the same idea as an extension cord, flexible, but you can buy them in many pair cables. It'll have one big cable that runs from the generator up to my closet where the breaker box is going to be. It's going to have one big junction box in that closet. Under the closet, it's going to be typical like RV closet where it's got doors you open, you know, and your clothes hang. Under those doors will have a set of big drawers. You pull the drawers out. If you pull the drawers completely out, under the drawers is going to be the furnace. All of this electrical stuff that I'm talking about, a couple of really large, well, probably just one, a large junction box. It'll have the low voltage breakers and resets and stuff in it. I'll have to have some really large cable too to pull from the batteries to the inverters. And I'm going to go ahead and maybe run a couple of cables up on the roof if we want to put some solar on it later. But anyway, this portable power cable is going to come from the generator to this breaker box. I'll have another piece that runs from that breaker box to the coach. We're talking probably a 30, you know, like a 15 pair cable, 30 wires. And that'll give me a good clean shot to run on my low voltage control systems, the coach lighting and all that stuff to that big main breaker box where I can put fuses and some relays for the, you know, where you have a different fuse for your lights on your coach as compared to the ones on your trailer or whatever. That'll make that system really clean and easy to deal with if you can bring all those cables into one big junction box and join everything right there. Anyway, I've already got the video shot. I installed one of the air conditioner control systems, but let's cut to that, and then at the end I'm going to install the breaker box. I fixed to get up here and hook up this air conditioner control system. I've only got a single one of the control boards in. I'm fixing to hook it up. Another one's coming. It'll be here Friday. I've sort of already got the wires run. I know this is going to look pretty complicated just for one air conditioner, but send it. All through this coach, I'm going to run these orange extension cords. Just the regular old, you know, Harbor Freight Walmart orange extension cords. And the reason for that is if you buy low voltage wiring that's not in a loom together, it's easy to chafe. And I plan on this coach lasting the rest of my life. I want to have this thing when I'm 75 years old. I'm going to run that orange cord everywhere low voltage is going. High voltage will all be run with, you know, the 122, 08, 240 will be all with the Romex, or some of them maybe MC. But anyway, you'll see those cords, and that's not just because I'm cutting up extension cords to use them. There's actually a reason behind that, because you have 3 conductors, typically 16 gauge, which will run any of your control systems or any of your, you know, low voltage lighting, and it's inexpensive, and it's got an extra big PVC, you know, tough coating on the outside of it that you got to cut through before you get to the wiring. So this is the typical 4 conductor foam cord. I cannot remember the name of this. It is non-stranded, it's solid 4 conductor foam cord. This must be daisy chained between each air conditioner and the control panel. And I'm a little bit concerned about the longevity of this wire because it is a solid core wire, and I have pulled an extra set of these to everywhere. So I'll have an extra wire already under the insulation and you know, under everything when this is finished. If I ever have a failure of this cord, I can simply put new ends and re-plug into this. So let's talk about the low voltage circuitry here. So I've got 2 of these orange extension cords. One of these cords will deadhead, and it'll be a relay that'll turn off and on the diesel fired furnace. So these 2 blue wires are the ones that trip and turn off and on it's just a relay. The contacts that will turn off and on the diesel fired heater, and it goes back, terminates to my breaker box. The other one is actually the 12 volts that will power this air conditioner control system, and it's going to daisy chain back to this. There's another air conditioner just right off camera, and then it'll go down to my junction box. So I'm gonna solder up these all these little wires. I'm gonna heat shrink everything. I'm gonna put this control board up here, put the first layer of this air conditioner on, not the actual plastic part, but there's a big metal shroud that goes on. And then I'm gonna plug the thermostat in. I'm gonna see if I can get this thing to work. Now this little control board, it should just more or less plug in everywhere. You probably can't see, but I've got a gap right here, and I've got to put these wood spacers I made to temporarily take up the gap. When I put the actual ceiling in here, that will be accounted for. Per Dometic spec, it says to put a self-tapping metal screw right there. I was trying to feel around up in here, make sure it's away from all the wires. I don't like this design at all. Okay, this is quite Frankenstein, but let me show you what's going on. Here's our air conditioner. There's the other air conditioner. It's not hooked up yet. We have a 12-volt power supply. Bring your 12 volts into where it will daisy chain on that one so that this board is powered off that 12 volt power supply. We have that piece of Romex, which powers this, I think, hooked to an extension cord plugged in. There's going to be, this is going to be the bathroom wall, and I'm planning on this thermostat mounting roughly right here. This will be like the kitchen counters right here. Well, nothing happened. Let's try this again. So apparently you got to hit the on button. It says turn it off, hit zone and mode, and it's supposed to program itself. Zone 1. Next, which will probably end this video, is I want to get my breaker box mounted. I'll explain where I'm going to put it. I want to temporarily bring my big cable in from the outside, hook it up to the breaker box. I'll go ahead and use the neutral in it. I'll explain later why you need to have a separate, why you can't tie the neutral to the case as you typically would in a standard breaker box. I get the air conditioner wires ran where I can turn the air conditioners on, and I want to get a couple plugs mounted. As I was talking about earlier, my 30 amp circuit that's going to sort of go both sides is going to be the cooking circuit. I want to try to get it hooked up good enough that I have a couple plugs in here so I can work or whatever. But it's like, I bet it's 140 degrees in this thing actually, and the air conditioner doesn't seem to help much. I'd like to get that hooked up so I can sleep all day, or maybe sleep from noon till 8 o'clock and then come work down here from 8 till 3 or 4 in the morning. So I've got this little stick welder. I bought this on vacation in Alamos, I think Alamosa, Colorado. I had a problem with my little teardrop camper and I had to have a welder. And I actually was able to run this little welder off the 2000 watt inverter and the two 12 volt batteries that was in my teardrop. But anyway, I'm going to use it in here. It's not much of a welder. If I had a little handheld wire welder, I'd bring it in here, but my wire welder is a big old ESAB machine. And I'm going to be mounting all my breaker box, all the boxes and the handy boxes and stuff with this little welder in 6010. It's a pretty slick little welder for what it is. It works. So if you can see, this stud right here, or whatever you would call this, is set off the wall. It's going to be the wall right here. It'll be the inside of the closet. I'm going to mount my breaker box right here on the edge of this, and then above it and below it, after it's spray foamed, it'll have a 2x4 mounted right here, and I'll be able to staple my wires up to it, and the 2x4 will break up the thickness of this so that the faceplate sits flush against the inside of the wall. And then you'll get to it by simply opening the door of the closet, and it'll be right here on the inside of the wall of this closet. Okay, this cord is going to be temporary because my main box will be underneath the sink, and it'll have the main breaker and the transfer switch. So anyway, when I put this in, I'll put a Romex clamp in here, but this is just temporary for now. Now I'm going to hook my neutral wire up to the ground bus, which typically would be how you would do it in a house. Now this is a problem in a motorhome, and code calls for when you run a breaker box to a different building, you must run separate neutral and ground wires and have an isolated neutral. And the reason is the voltage drop coming back on this neutral cable will cause the coach, the frame of the coach will be energized with whatever the voltage drop is. So if you've got a couple of volts voltage drop, when you grab a hold of this coach and ground, it will tingle. Now, I'm going to put up with that while I work on this, but when this is finished, this will have a isolated neutral where all these neutrals will be brought together with a big Kearney clamp or something, and then the ground will actually be gathered up here in the ground bus. So I'm going to have 1/4 inch plywood over all this on the inside. My boxes are 1.5 inches deep, my studs are 1.5 inches deep, so I'm going to space this about 1/8 of an inch roughly off the back wall so that there's about 1/8 of an inch sticking out. And when I put my 1/4 inch plywood over it, this box will be in the wall 1/8 of an inch. That box is going to be a permanent location for a plug, but the plug installation is going to be temporary. I've got to run this through the roof, and I've got to drill a whole bunch of holes and a bunch of stuff yet. I'm just going to loop this wire around the wall and stick it in the breaker box, just so I can have a plug to use and I get my cords and stuff out of the door. So I got my plug hooked up. It works good. It's temporary, but whatever. Both air conditioners wired. My next step is just to mount all these boxes and pull that Romex everywhere. I got to drill a bunch of holes in the ceiling joist and put grommets in them. It's just not going to be something really worth videoing. If there's an anomaly of any kind that's RV related or anything unusual, I'll grab the camera. But as far as the 120 volt stuff goes, if you want to watch somebody wire a house, I'm sure there's lots of people on YouTube that can wire a house and show you how. And I wanted to put my stereo in here and crank my radio up where I don't have you can't listen to the radio on your recording for YouTube. But anyway, appreciate you watching. Thumbs up, subscribe, bell, like, ding, whatever. Catch you next time.